So yes, my screen is visible. Okay. Yeah, no, it's fine. So find V out. Okay, find V out. The op-amp will work in single supply mode. Anyone try to solve it? Yes. Anyone? V naught is 4. Okay. Hmm. 1 kilo. 2 kilo. 1 kilo. 2 kilo and 10 kilo. Okay. Now, initially we are assuming that all resistors are equal. Now we are changing the value of resistance. Now what is the V naught? 12 volt. Any other? Now the thing is that V naught is equal to 1 plus Rf by R1 time Vi. Okay. So it becomes a 1 plus 10 divided by 2 times 2 volt, that is 12 volt. Now this 12 volt will be exceed greater than the operating range. Okay, 12 volt is greater than the operating range. So what is the value of V naught? V naught value is 10 volt. Always remember this thing that your voltage, output voltage doesn't exceed with the range. If I
Sir,
connect, yeah,
sir, if the voltage output exceeds the operating range, then the signal will be clipped, right?
yeah, actually we in the last class, if you remember that we draw one characteristics. mm, yeah,
Yes, sir.
this is my, okay, Vi minus V1 minus V2, and this is the V naught. So after a limit, it will be constant. After a limit, it will be the constant. Okay, and what is this limit? This is the plus VCC, or basically the plus supply, and this is the negative supply. Okay, so V1 and V2 is if increases, so that doesn't means that V naught is also increases. After a limit, this is the VCC. After a limit, it will be constant. Okay, the similarly the thing is that if till, in this case till 10 volt it is increases, after that it will be constant. Okay, now if we are relate this diagram with the this particular circuit, so we know that VCC is the minus VCC is with the ground, negative supply is the basically grounded, so only the curve will be like that, this one. and this one. Why? Because negative voltage is not possible. Negative V out is not possible. If your V1 minus V2 ratio is negative, okay, if V1 minus V2 is negative, clear?
Then we will add the mean voltage.
Just what you are saying actually, Sanket.
So we will increase the limits.
Hey, wait a minute, actually, I am not getting your voice. Hmm. Yeah, now tell me. Sanket, can you tell me what you are asking?
No.
Okay. Clear any doubt? Find the output voltage.
Sir, 5.25.
We notice
5.25.
0.25. Answers. Yes, any other answer? So you have to apply the superposition theorem. Okay. So firstly, I consider this one. So the direction of flow of the current is this. Okay. So because of this 1 volt, I am getting a minus RF by R1 into 1 volt. Okay, so this is the minus 10 divided by 2 into 1, that means minus 5 volt because of the first source. From the second source, this one, the direction of current is this. So that is minus RF by R1 into 2 volts. So minus 10 by 4 into 2 volts. Okay, so it is again in minus 5 volt. Now this is the third one. Okay, for the third circuit, this one is the grounded. Okay, so the voltage at this point is different. Because of this third circuit, the voltage at this point is what? 1 multiplied by 2 divided by 4. I have to apply the voltage divided by 6. So 1 multiplied by the voltage drop across this resistor divided by total overall resistor. So that is, at this point the voltage is 1 by 2. Okay. Now Rn is also the parallel combination of these two. So Rn is what? 4 parallel with 2. Okay, so that is the 8 divided by 6 or 4 by 3 kilo. Okay. Now with the help of third circuit, I am getting 1 plus Rf by Rn into voltage 1 by 2. Okay, this voltage. So that is equal to 1 plus Rf is 10, Rn is 4 by 3 into 1 by 2. So 1 plus 7.5 into 1 by 2. So 8.5 into 1 by 2. That is 4.24. And because of the fourth circuit, this is the fourth one. Okay, so this one is grounded. Okay, so voltage at this point is what?
2 by 4.
Voltage divided by single 2 into 2 by 4. Okay, so voltage drop across this resistor 2K. Okay, divide by total overload resistance 2 divided by 4. So this is the one. The remaining thing is same, 1 plus R by R1 into 1. Okay, so that is a 8.5 multiplied by 1, that is 8.5. Okay, so overall V out is what? -5 plus 8.5 plus 4.25.
2.7.
2.7. Okay, so this type of mistakes, remember that negative, no effect, but positive resistance if are connected in the parallel, so they will create a effect. On a negative side, no effect. Why? Because negative, there are the way to pass the current at V0. Okay, they have a path to flow the current till V0, but in the positive side they don't have the current, so we have to find out this is the voltage. Now this voltage is equal to this voltage. That's why these other particularly points will be creating other parallel resistance will be creating the effect.
So,
Yeah.
can't we think like that? So just call down.
Which one?
There's a question we can think about is like the positive node. We think like a voltage V, okay, and
Mm-hmm.
the same voltage will be the negative one,
Mm-hmm.
and 1 minus V divided by 2 is equals to 2 minus V minus 2 divided by 2. So the current entering
You
from
are
1
applying
volt into
the KVL, KCL
KCL,
okay.
and okay,
From this one
and
and from this one, from this one and from this one. Okay,
yeah,
to find
and
this
after
voltage.
that we will
Yeah,
find
you
the
can do
voltage
that one.
and
You
same
can do that
voltage.
one also.
Okay,
Okay. For the particularly
it's a
third
easy
and
one.
fourth, you can apply that one.
No. For whole question, it can apply now. We will find the voltage at positive voltage, and then
Yeah.
that will be the same voltage at this uh, negative side,
But the thing
and
is
we will
that
apply.
thing is that when you apply, both will be same. Okay. So basically the voltage
Mhm,
apply at this point V1 is different. Okay. Now if we are getting a point voltage is 0.75.
mhm.
Okay. So how this voltage will be equal to this voltage? If these are not connected, so we can say both terminal voltage will be equal.
So
Wait a
uh,
minute. I just
no
tell
current
you.
will enter to positive and negative like op amp now.
Mm-hmm.
The voltage will be same positive and negative. So we just think about 1 minus negative voltage and plus 2 minus negative voltage divided by both the resistors is equals to uh,
Wait a
the
minute.
negative voltage minus V out divided by resistor. That's
Like
easy way
for
to solve it.
example, we are saying that this is the 2 volts.
Okay.
Okay. Now negative, we are saying this is the ground. This is the resistor. Okay. Now what we assume that at this point the voltage is 2 volts.
Hmm.
Okay. Now the same voltage will be
Okay.
applied at here. Why? Because it is a
Hmm.
negative feedback. Okay.
Yeah.
This particularly 2 volts will be appear here because of this V0. Because when the V0 is there and the ground is there, so the current will be flowing in this way.
Yeah.
Okay. Now if the current will be
Yeah.
flowing in this way, so that means there are some drop across this resistor, and we are assuming this particularly drop is 2 volts. Why? Because of a virtual ground concept.
Yeah.
Okay. Now if I connect a battery here of
Okay.
3 volt, now can you say that it is again a 2 volts?
So the current entering the negative side, not the negative side, the resistor Rin will be leaving from RF. So we
Now,
can apply that.
so like for example, you just calculate that one. The first thing you assume that
So
this is
let's
the
suppose.
grounded. This is the grounded. What is the output
Okay.
voltage?
Vout
I
is
say
equals
that
to
2 kilo
the 2
ohm,
volts. So
2 kilo ohm and 10 kilo ohm.
okay. So
So that is 1
it will
plus
be 12 volts.
1
1
plus
plus
say 5.
10k by 2.
Yeah,
Yeah,
5 divided by
into
2
2.
multiplied by 2 is the 12 volts.
12.
Okay. Now if I connect a 3 volt here,
Okay.
now apply the same method that you applying and check the Vout is same or different.
Okay. So we can say that the positive side of the battery. Let's suppose we have V. Okay. So
Mm-hmm.
V minus 2 divided
Mm-hmm.
by the 2k is
Mm-hmm.
equals to 2 minus V naught divided by 10k.
Okay. So I
3.
just
Okay.
say that
So
3 minus
3
2
minus 2 divided by
divided by
2k
2 is
is
equal
equals
to
to uh, so 2
2
minus
minus V
V
naught
naught by k 10k.
and
We can
okay.
solve it.
So this is the 5. Okay.
Yeah.
So if I
And
multiply
that
5
will be 5, 5,
2
and
minus
then
V naught.
minus 3.
So V naught is minus 3.
Minus 3.
The answer is change.
Yeah, no problem.
Okay.
I was saying last part.
Now the thing is that you can apply the superposition theorem in that one and check the answer.
Yeah.
Okay.
Okay.
So because of this 2 volt, I am getting 2 volt. I am getting a 12 volt. Okay. Because
Yes.
1 plus R by R1. So because
Mm-hmm.
of this one, I am getting a 12 volt.
12
Now
volts.
because of this one, what I am getting minus 15 volt. Okay. So the answer is minus 3 volt. Both answer are
Same,
same. You
same.
can apply that one.
Yeah, that's why I was saying like
Okay.
just the easiest.
Yeah. You can apply that one.
Okay. Right.
Okay. Better thing is that apply.
Yes, sir. Thank you.
Like that. Any other doubts? Now the similar type of question is that V1, V2, R1, R2 minus V0, RF, V3, V4, R3, R4. Okay. Find the value of R1, R2, R3, R4 and RF in a way that output voltage V0 is 6V1 plus 8V2 minus 3V3 minus 5V4. Yeah, and assume minimum resistance is 10K. The question is random, so maybe you are getting the resistance value as a negative part, okay, but ignore that negative part. The question is random, okay, so ignore negative value of resistance. Okay, that means if you are getting any particular resistance is minus 10K, so we are assuming that it is a 10K.
can we assume R1 and R3 as a 10K?
You can take that one. That is dependent on the particularly value, but the minimum resistance you are getting, that is the 10K.
So from all four resistors, we can assume one as 10K.
Yeah, which one is the minimum?
Okay.
Sir, the equations are not validating, sir.
Which one?
So when we try to find the voltage output voltage across V1 and V2, sir,
Mm-hmm.
sir, the R1 upon R1 plus R2 is getting 8 by 9, and R2 by R1 plus R2 is getting 6 by 9, sir. So if we assume R2 is smaller, then R1 is getting 5, sir.
Okay. So this condition is not valid.
Yes, sir.
Okay. Yeah, so I just tell you that this is a random, so maybe possible. Any other? Everyone getting the same?
So I calculated everything in terms of RF. So
Mm-hmm.
R4 is equal to RF by 5, R3 is equal to RF by 3, and
Mm-hmm.
1 by R2 plus bracket में R1 plus R2 divided by R1 R2 is equal to 8 by 9, and
Okay.
1 by R1
Mm-hmm.
R1 plus R2 divided by R1 R2 is equal to 6 by 9.
Okay. So any value you are getting?
I'm confused, like what value we can take 10K, like if we take R1 as 10K or R2,
Okay. So
which value to take 10K.
first of all, I just calculate the equation. Okay, if V3 and V4 is we apply. Okay, so because of V3 we are getting as a minus R1 RF, sorry, RF by R3 times V3 is equal to V naught. Okay, because of V3. Similarly, because of V4 we are getting a minus RF by R4 times V4 is equal to V naught. Okay, if I equate this term and this term with respect to the V naught term where V3 is given and V4 is available, getting that minus RF by R3 is equal to
-3.
-3. So that means RF
It's 3 times to R.
R3, we are taking the R3 is equal to RF by 3. And similarly, R4 is equal to RF
RF
by
by 5.
5. Okay. So these are the R3, R4. Now we go with the V1 and V2. So because of V1, we are getting the voltage 1 plus RF by R3 parallel combination of R4 times
R2 by R1 plus R2
R2 by R1 plus R2 into
times.
V1 is equal to V0.
Yes, sir.
And we are getting that V1 is, if we equate this one, so it is a 6. This one is 6. Six V1, so V1 and V1 is cancel out.
We can write R3 and R4 in terms of RF.
So that is the R3 parallel with R4, that is equal to R3 into R4 upon R3 plus R4. So if I calculate this one, so RF by 3 into RF by 4 RF by 5 divided by R3 plus RF by 3 plus RF by 5.
RF by 8.
So we are getting a RF square upon 15 divided by 8 RF by 15. 15 if 15 cancel out, so RF by 8. Okay, so 1 plus RF upon RF by 8 times R2 upon R1 plus R2 is equal to 6. So RF cancel out, so this is the 9 R2 upon R1 plus R2 is equal to 6. That means R2 upon R1 plus R2 is 6 by 9. Okay, and we can say that 9R2 is equal to 6R1 plus 6R2. So 3R2 is equal to 6R1 and R2 is equal to 2R. Okay, so this is the first, this is the second, this one we are taking as a third. Okay, now we are apply the V2. So V2 is equal to 1 plus RF upon RF by 8 times R1 upon R1 plus R2, that is equal to 8. So R1 upon R1 plus R2 is equal to 8 by 9. Okay, so this is 2 are different.
Yes, sir.
R2 is equal to R1 by 8. This is a great question. Here we are getting R2 is equal to 2R1 and here we are getting the R1 by 8. Can we solve it for the 3? Okay, if I change the equation as a 3v2. If I change it as a 3v2, so we are getting 3r1 plus 3r2 is equal to 9r1. So 3r2 is equal to 6r1, or r2 is equal to 2r1. Okay, question number 4.
Yes, sir.
Okay, so we have R3, R4, and R1, R2. So R3 is RF by 3, R4 is RF by 5, R1 is equal to R2 is equal to 2R1. Okay, so we have a choice that we can choose any of the resistance R1, R2, R3, R4, and RF as a 10 kilo. Okay, we have a choice. Now if we say that R1 is 10 kilo ohm, so that means R2 is 20 kilo ohm. Okay, and if I choose RF is 10 kilo ohm, because R3 is 10 kilo ohm, so that means RF is what?
30.
30. Okay, and if RF is 30, so R4 is 6 kilo ohm.
Yes, sir.
Okay, so if R3 is 10 kilo ohm, so RF is less than that one, and we have a limit that minimum resistance is 10 kilo ohm. So we are choosing that R4 is 10 kilo ohm. Okay, so if R4 is 10 kilo ohm, that means RF is 50 kilo ohm. Okay, if RF is 50 kilo ohm, that means R3 is
50 by
50
3.
divided by 3, that is 16.66 kilo ohm. Okay, these three resistance we have calculated. Now what is the relation between R1, R2 and RF? So we go with the equation number V1, this equation.
Yes.
Okay, we go with this equation. So 1
काय
plus
छान रिप्लाय का त्यांच्याकडे आणि ते
RF
तिकडे
upon
गेले.
R3 parallel with R4,
हा ना ते स्टेशन आवाजात नाही.
R1 upon R1 plus R2, that is 3, or R2 upon R1 upon R2 is 6. Okay, so I can take any of the equation, either V1 equation or V2 equation. Now put the value of R3 and R4. Okay, so R3 is 50 by 5 and R4 is 50 by 3. Okay, so we are getting no, not in this way. We have to assume either R1 or R2. Okay, we have to assume R1 is also 10 kilo ohm because there is no relation between R3, R4 and RF with R1 and R2. Okay, so both are basically, if you see that, independent. So you can assume R1 is also 10 kilo ohm. Okay, so if R1 is 10 kilo ohm, R2 is 20 kilo ohm. Okay, so these are the three values and these are the two values. Now any doubt?
No, sir.
Now in the next class, we basically solve the question related to the capacitor. Week 3 capacitor related questions. Okay.
Sir,
Yeah.
in first question of the today class, there
Yeah.
was a battery connected with voltage divider circuit.
Hmm.
Yeah, this one. Why
Hmm.
it's there 10 volts battery?
I'm just assuming that this is a 10-volt battery.
Why is that connection like 10 volts and resistor and one
Basically,
parallel?
that particularly connection we are taking because what should I do? Like for example, if I remove this circuit, if I remove this part, okay, let's say I remove this one, okay, and convert into the 5 volt and 5 volt, 5 volt and minus 5 volt.
So yeah, okay. You are
Okay,
making
so that
simple.
circuit is simple. Okay,
Yeah,
now what I do, I just shift the level by changing, adding 5 volt for both supply.
got it.
Okay, so it become a 10 and ground. So that when we are going to shift the level, we have to shift the input signal also. Why? Otherwise the range will be the may be possible that it is a negative or some higher range of that one.
Yeah,
Okay, initially my range is what? Input signal range is minus 5 volt to plus 5 volt. Now I can, my range is changed from 0 to 10 volt. So I can change the input level also. So my range will be remain constant, maintain. Okay, so that's why I just use one VCC with the 10 volt and apply the voltage divider by C. Okay, so 10 volt with the drop of 1 kilo ohm and 1 kilo ohm equal resistance. So the drop is constant. So here we are getting a 5 volt.
so we won't like solve this question by 7 volts. We will solve with the 2 volts only.
No, no, no. Actually, this particularly is only to increase the level. If you go with the
Okay.
single supply operation, okay, say because of the single supply operation, what we are doing, if I change the voltage of this one, if I change the voltage of this one, okay, I introduce a 5 volt also here. So we are getting V out same, no change. Why? Because we increase the level. Sorry, V out plus, sorry, V out plus 5 volt is there. This is the output. You attend the last class?
No, sir, I will.
Okay. So I will explain that one in tomorrow class. If we increase the all the levels means both supply voltage, non-inverting and inverting terminal voltage. So my output voltage also shift by the 5 volt.
Yeah, I watched the lecture, so I understood.
Okay. So
Okay, sir.
that particularly voltage will be increased.
Yeah.
Okay, now the correct thing is that if I change the voltage to 10 volt and the ground, my output voltage is increased by 5 volt. Now after adding the 5 volt, we are already getting the 12 volt, and after that 5 volt, my overall voltage, output voltage is 17 volt, but the range is what? 10 volts.
0 to 10.
0 to 10. So that means the output doesn't go beyond the 10 volts.
10 volts. So it will click to the 10 volts.
Yeah.
Okay, sir. Thank you.
Anything else?
No, sir.
Okay. So we will stop here.
Thank you, sir.
Thank you.